Hey everybody, welcome to Cloud Lunch and Learn. This is the second session in the series, So You Want to Be an Azure Solutions Architect Expert. And today we're going to focus on IaaS. And I will hand you over to Dwayne, who can get you all, turn you all into experts.
I don't know if these sessions are going to get you quite to the expert level yet, but it'll get you at least pushed in the right direction. So thank you very much.
On the right track.
Thank you very much, Lisa.
No worries.
So yes, as Lisa was saying, this is the second session. This is the first one that is focusing on a specific objective area. We're focusing on the infrastructure as a service topics and objectives for the Solution Expert exam. So for those of you who's missed any of the sessions previously, my name's Dwayne Natwick. I'm a senior cloud training architect for Opsagility and a Microsoft certified trainer regional lead. I hold multiple certifications, including my Solution Architect Expert. So we talked about last session, the key objective areas. So as we expand into these next sessions over the next 4 or 5 weeks or so, we're going to touch on specific areas for both of the exams. Actually, the 300/303 exam, which the 303 exam, which is the new first exam for the Solution Expert certification, actually went into beta last week. But you can still take the AZ 300 exam up until September 30th. So they're really kind of running dual exams right now. If you want it, one thing to point out, if you want immediate gratification to know that you passed the exam, take the 300 or the 301 exams that are running through September. If you're planning on being ready for one or both of those exams by September, take those first, because until the 303 or 304 come out of beta, which will probably, my guess would be probably around September 30th, you will not get your results until after those come out of beta. So that's important. If you are taking the 300 and you don't get to the 301 before the 304 goes live or the 301 retires, any combination of the first exam and the second exam will get you your certification. So if you take the 300, you don't get to the 301 before September 30th, you take the 304, you still will get your certification. So don't worry about that. And even though these exams are retiring, your certification is still going to be ready for 2 years. So just some key points there. I'm going to the areas that I'm going to touch on today are infrastructure as a service topics, and I'm going to point out, we're going to talk about implementing virtual machines, virtual machine sizing, managed storage, encryption, desired state configuration. These topics here, something to take into account, because we are focusing on both exams in this series and objectives for both of these exams. A key point is Azure Backup and Azure Site Recovery is a key area tested on in the second exam. So you may not need to know a whole lot about Azure Backup and Azure Site Recovery as objectives to the first exam, but you definitely need to be comfortable and know the steps that you have to go through for the second exam. So I just want to make sure that you know that. Same thing with like virtual machine sizing. Since the second exam is around designing for Azure, knowing what the virtual machine sizes are and what use they have and how to select them is going to be very important on the second exam, not as important necessarily on the first exam. First exam is very administratively focused and deployment focused from that standpoint. So keep that in mind as we go through these topics today. Make sure as you're getting ready to prepare to review the objective areas, which are here on these slides as well as the links. And like we did last session, we'll share this slideshow out on the Cloud Lunch and Learn GitHub, as well as this is being recorded, so you can review and go back but this is easily accessible. These two links from the Microsoft Learn page, you can go in, find the exams, and find these objectives very easily. So make sure you're aware and understand which objectives are focused on the particular exam. So I'm going to highlight some things around each of these topics, and then we're going to go into the Azure portal to show you a little bit of how it all works for those of you that may be newer to Azure and don't understand, the deployments and things like that of a virtual machine, infrastructure as a service type environment. We're going to go through that because that's very important for this exam. But we'll highlight some key areas before we go into that. So some key things to know around virtual machines in Azure, the operating systems, and knowing what operating systems are available when you deploy a virtual machine. These are the standard operating systems that if you're not doing a bring your own license or building your own custom virtual machine, if you're just launching a virtual machine directly in the Azure portal, these are your selectable operating systems that come fully licensed when you launch that virtual machine. It's all built into the cost of the virtual machines. You don't have to bring your own license or have your own licensing and software assurance when you do that. So it is generally for the Windows operating systems, any Windows operating system that's still under the full support of Microsoft. So right now it's 2016 and 2019 data center, as well as R2 2012. So that's as far back as it goes. Many of you may know that 2008 server went end of life, end of support back in January, and they pulled that off then. But like I said, if you have your own enterprise, if your organization has its own enterprise agreement with Microsoft with those licenses in there, you can actually bring your own license into Azure and get 3 years more of security patching within the Azure environment, which is very costly if you have it in your own data center and you're trying to run that. Linux, you can see many different Linux operating systems are supported. You have 2 Ubuntu options. You have a Red Hat option, a SUSE option, CentOS, and Debian options within the Linux. So whichever Linux operating system you may be comfortable with or may use in your environment, you can bring that in to your Azure ecosystem as well in a hybrid architecture. So I have a link here that goes a lot deeper into the Azure sizing, but I wanted to make sure I covered it excuse me, within today's session, and that's the sizing within Azure. And I've got them grouped here just really quickly in different workload types, which is generally when you're asked to choose a virtual machine size in within the Azure portal or within the exam. They're going to give you some sort of scenario and ask you to choose what the machine, what series machine you're going to have. They're not going to get really deep into it. Key point here when reviewing the chart is you can see that there is a D size series, the DSV2, that is in the memory optimized grouping. It's the only D series that falls into that memory optimized, but the D series is also in the general purpose. So if you get a question of you need a general purpose machine that's memory optimized, it's probably a good idea to know that this is the machine to discuss and to know. And then the other ones are like the ones that are a single series within the type of purpose and type of workload, which is, you have your compute for the F, your storage optimized, your GPU optimized, and your high performance. Unfortunately, the lettering scheme isn't the easiest to remember. You have in memory optimized, you do have the M, which makes it easier from a mnemonic memory kind of situation. And same thing with the high performance, you have the H, but it kind of gets confusing with the compute being F, storage being L, and GPU being N. It's a little harder there. You can see that with general purpose and memory optimized, there's multiple series in there. So make sure you understand those. Maybe a little bit for the first exam, but if you're taking the second exam, you generally get some questions around selection of a proper virtual machine series.
Dwayne?
Yes, Lisa.
Quick question.
Yep.
Licenses for RHL are not included with the image, right?
No, I believe that they are. I believe you might still have to do management with RHEL, but I believe if you're when you're selecting it and building it directly within Azure, that you get a licensed version.
Okay, cool. Thank you.
But I think, yeah, if you need like management with RHEL, that and Red Hat gets IBM gets a little weird with some of that, so I don't quote me on that. And I'm not an expert on RHEL licensing, but generally you get your license as part of it. But if you need any additional management, I think with RHEL, because it's it's Linux, so it is open architecture, but it is an IBM operating system, so I think there is still some management fees you would need to do from a support standpoint. That's not included, but I believe the actual licensing is. So it's a little weird with that one. A lot of people generally gravitate more to like Ubuntu because it is truly open source rather than RHEL, as well as SUSE gets a little weird with that as from a support standpoint as well, and can get a little bit more expensive than some of those other ones like CentOS and Ubuntu, particularly because those are truly open source operating systems. All right, storage and encryption and baselines. I wanted to hit on these a little bit here. One of the key things to understand is when you are doing virtual machine storage and virtual machine disks, Microsoft recommends the preferred type of disk is having a managed disk, not to connect like a blob storage or file storage account to your disk, but use managed disks. So that's generally something that you can see in terms of a storage type question on the exam. Your disk options are a standard hard drive. Spinning disks would be the term to use there. And then there's a standard and a premium SSD for operating system disks. If you're using some of the VM sizes, say like memory optimized disks, you might find that the Ultra SSD is also an additional option. If you're taking the 303 or the 304, you may see the Ultra SSD appear in some of the questions. The difference between the standard SSD, premium SSD, and Ultra SSD is really just the IOPS and the speed of those disks. So it's important, if you're talking about memory optimized machines or disk optimized machines, you're probably going to see the Ultra SSD. The standard, for the most part, you see a default as the D series for most workloads within the Azure environment, and those have the SSDs for the standard and premium generally. Azure disk encryption, important to understand all disks and all storage within Azure by default is encrypted at rest. So it is encrypted at rest. If you create if you create a disk within the Azure environment, when you're creating a virtual machine, so that disk gets encrypted, but the important thing is to know that your operating system is not encrypted. So they use storage level encryption. It's SSE is the storage service encryption, is the standard encryption for all your disks and all of your storage within the Azure environment. But to get full encryption of your virtual machine, so you have your virtual machine, you want to encrypt that virtual machine at rest, the image of that virtual machine, all the snapshots and all of those areas, you need to enable and use Azure Disk Encryption. And that gets you the full encryption of the disks and the operating system. So a little differentiator there. If you see a question around what encryption do you use for your operating system and disk, it's not SSE, it's ADE. So those are some things to just know around the encryption piece of storage and understanding that. If you're looking to create a baseline of your virtual machines and have kind of your own organizational security and extensions, and we'll talk about extensions, but extensions are generally you're running your own type of malware services. Say you're using Semantic or something of the like for anti-malware and virus protection on your servers. That is your corporate standard. You can have that extension and have the build of that virtual machine as created as a baseline and have baseline code that you can run as a desired state configuration. And you can have that desired state configuration be how those servers are deployed. The thing around desired state configuration is you need to have a good understanding of PowerShell and deploy your servers using PowerShell or CLI code rather than being able to just go into the portal and create a virtual machine. So a little different there, but it's important to know desired state configuration and how desired state configuration works within the environment. And I'll hit on where that falls within the portal and everything, where you can see that and can go into the portal and understand that in a moment. I'll pause for a second there. It seems like we've got a couple more questions, Lisa, if you want to hit me up on those before I move forward.
Yeah, so one question was, what are the uses of baseline in resource creation? But I think you might have covered that.
Yeah, I think I did hit that because I think they did ask that on the previous slide. So
yeah, they're ahead of the game.
All right. Key thing, and I did. If anybody also is following the Skylines Academy summer sessions, I did a summer session on scalability and availability that was on YouTube a couple weeks ago. But I wanted to hit on this because when I'm teaching the architect course or the admin course, which these both kind of a lot of this falls into both of those objectives, scalability versus availability becomes a little bit clouded. So it's important to understand that the similarities and the differences in the two, and we'll talk more about it when we go into the deployments as well. But I wanted to just kind of hit a couple slides around this particular piece because selecting and understanding these are an important component of a IaaS environment in Azure. So you want to understand how to segment the two, essentially. So when you think about scalability and availability are both a scaling out of resources. And when we talk about scaling out and scaling in, which is important to understand those within the Azure and Microsoft terminology, when you talk about scaling in and scaling up and down, we're talking about essentially increasing your subscription. So if you're in a say a D1 series machine and you want to go to a D2 series machine, that is scaling up. And if you want to change that and scale down to a D1, that's scaling down. So when you're changing a size of a single resource, it works in app services as well, where you're maybe at a development app service and you are going to go to a standard subscription level app service. That's scaling up and down. So you're scaling your subscription, you're scaling a single resource. Scalability and availability are different, where they're adding more instances of that resource. So you're scaling out those resources or scaling in those resources. So you think of it as more of a horizontal rather than a vertical type of change within your Azure ecosystem. But they both scalability and availability work in that way. The difference is that scalability is to add additional resources to meet an increased demand, and availability is to maintain, obviously, the availability across multiple resources. And that falls into a very important cost component of the Azure environment, where you pay for from availability standpoint, you pay for the resources that are running, and those resources, based on what availability you want to have, becomes more expensive because you're running full time that number of resources that you define. And we'll talk about that when we go into the demo as well. With scalability, you're only paying for those resources that are turned on. So you're decreasing resources and increasing resources as your demand goes up and down. And we'll talk about some use cases here in a second. We'll go deep into that, but understand that, availability is generally, you're going to define that this many resources are going to run, where scalability is, oh, my demand is increased, I need to increase my resources. And here's a graph that kind of shows that scaling. So your CPU, it's very dynamic. You start with, say, one machine, but your server has an increased demand, so it adds another virtual machine running that application, and then you have a load balancer running that's balancing that virtual machine. As you increase, your CPU increases again, it'll add another machine. As it decreases, those resources then scale their way in back to your original defined number of virtual machines that you have in budget. So you may see a decrease in cost short term, but long term you're still running at your normal capacity. For availability set, you're defining, though, now how many servers you need to have available at a certain time. And those generally are defined by fault domains and update domains. Your fault domains define how many racks within the Azure data center your servers are going to run on. That way, if there's a unscheduled maintenance on the PDUs or the switches on a particular rack that take down that rack temporarily, that you still have other racks that you have virtual machines running on. Update domain is very similar, but that's to cover you on maintenance, unscheduled maintenance on the hypervisor. The host needs to be updated, so you don't want all your virtual machines running on one host. This guarantees that they're spread across multiple hosts. Now, Microsoft does a good job to make sure that they move your snapshot and can move your machine for scheduled maintenance, as well as they do rolling updates. They're going to do a wholesale update across the entire ecosystem at one time. So that's why you defining different update domains is going to make sure that you're not going to, you may have one machine that's doing that is being taken down due to an update, but your other three are not in this particular example. So what is the use, and how would you use the scale sets and availability sets? So I talked about scale sets based on demand and the need for additional compute power for your virtual machines. The best example I always use when I'm talking about scale sets is an e-commerce site. You have probably pretty predictable static usage on a daily basis for 8 months out of the year on your website. But when it gets close to Christmas, you hit November, those needs and those resources go way up, and you need to have additional availability on, or scalability to meet that demand and scale out your resources for additional needs. In a traditional data center, you would have to make sure that your data center and your servers that you are building have the capacity to meet that demand from November to February, say. So, you've worked your way through Christmas, and then you have returns after Christmas. So you've got a 4-month window where your website is being hit pretty hard. You would have to, in a traditional data center, make sure that you had your application on a server that can meet that top end capacity, where you're maybe only using 30% of that the other 8 months out of the year. So you're wasting compute resources for the majority of the time. The beauty of Azure is that it allows you to build a server at that projected standard runtime need, and then can scale out as needed by adding additional servers to that environment when you have that increased demand. The availability set is important. Best use case for that is you have a global organization that has 24/7/365 operations. They're mission critical. They're global. They need to be available at all times. You can't afford an update in the middle of the night in the US because it may be prime production time in India or on the other side of the world. You need to make sure that you don't have that application go down at any time for any reason. That's where you use availability sets. You maintain that nothing is going to take those machines down, whether there's a fault on the data center or an update on the host. You have a number of virtual machines that are running.
Dwayne?
Yes.
Quick question.
Yep.
From a costing perspective, what's the difference between resources that are on versus resources that are running?
So if you have the machines off, you're generally not going to be paying for those machines, or you pay, if it's a reserved instance, you pay a fraction of it. But for the most part, if you have it turned down, it's not going to cost you. It's going to cost you, if it costs you anything, it's going to cost you pennies. When they're running, you're going to be charged the full cost of those machines. So that's why scale sets are very helpful from a cost standpoint, because you're actually until those machines are actually going to shut off completely and going to go away from your subscription in a scale set. So it's shutting it down, and that resource is going away from your subscription completely. So there is no cost to that virtual machine. It's not like you're reserving that machine at all. You have your number of machines that you're saying, I'm going to run, and I'm going to budget into my cost. And then I'm going to know that I'm going to pay for X number of machines because my capacity might go 4 or 5 machines beyond that during the Christmas season. So I'll budget that my normal machines, my normal 2 machines are going to be 4 or 5. So I'm going to have a 4-month cost that's going to increase. But those machines generally, when it scales down, are not going to cost you anything at all, because they're just shutting off completely, and they're actually removing themselves from your subscription. You're not actually reserving those virtual machines at that point. So you're not going to see any cost from that. Availability sets, you're going to pay X times for how many you deploy as an availability set. So it's going to be a 1-to-1. You say, I need to have, in this slide, you can see I've got a update domain of 5 machine or availability set with 5 machines over 3 fault domains and multiple update domains. I'm paying for all 5 of these machines.
Cool. And just another question on this topic. Is a VM that's on deallocated state, you're still paying for some of the components of it, right? So
yeah, if you are so if you have, say, disks assigned to that virtual machine, you might be paying still some storage for that. So that's really the main thing that you're going to be paying for. What, storage is always a cost that can really get out of control very quickly within the Azure environment. And I think I've actually got a session on storage that will talk more and more about storage and controlling storage. But that's your big component. When a server goes down in deallocated state, you may have backup snapshots, you may have disk storage, or a disk that you didn't deallocate that you're using, that you want to use again. That's where the costs lie. You're not paying any more for compute when it's deallocated. So the last point I want to hit on, and then we'll get into a little bit of demo for the rest of the time, is backup versus replication. So there's 3 key components when you're talking about protecting your data within the Azure environment. We'll talk more about this too when we get into the data and storage session in a couple weeks. But I wanted to hit on this because from a infrastructure as a service IaaS standpoint, understanding these 3 pieces are important around architecting your virtual machine environment. So it's key to know the difference between what replication is and what backup is and what services Azure has for this, particularly for, like I said, the second exam hits on site recovery is a key component of that. Site recovery, Azure Migrate are very key points within that particular objective set. So, when we talk about the storage accounts, and I'll hit on this really quick, is you have replication, and you have, if you're using local redundant storage, 3 copies, geo redundant storage, you have 6 copies. The important thing around storage replication is it's replication. So it's not backup. And if one copy becomes corrupt, all the copies become corrupt. If somebody accidentally deletes one copy and you don't have soft delete turned on, and you delete a copy, they all get deleted. So it's important to have soft delete turned on, use data lifecycle management to move storage to cool storage and archive storage to protect and maintain your retention policies within your organization. That's as far as I'm going to go on storage for now. Tune in on July 24th for more on this. Azure Backup is a little bit different, and both Azure Backup and Azure Site Recovery leverage the Recovery Services Vault. So the important thing around recovery service, so they both fall into the same area, where they utilize that Recovery Services Vault. Backup, though, protects against those corrupt images and files. They are backing up where you say, whether it's a daily snapshot, for your virtual machine and disks, whether it's an hourly snapshot, however you want to configure that, you can configure it. And configure then how long, and build retention policies on how long you're going to hold those backups. Azure Backup can do VM snapshots, disk snapshots, Azure files, and Azure databases, as well as can do on-premise. You can put an agent on-premise virtual machines and do a lot within your on-premise environment. So you can have one backup ecosystem all within the Azure Recovery Services Vault. In addition, Azure Site Recovery is an additional layer of protection that you can put within your environment for protecting against multiple servers or a data center failure, where you can recover those Azure servers and those on-prem as well as on-premise servers very quickly with very strong recovery time objectives. Where if you're only using Azure Backup, you can recover those servers. You can recover that snapshot manually create a new virtual machine from that snapshot, but you have some manual process. So your recovery time objective is going to be a little bit more, where Azure Site Recovery synchronizes the data center build essentially, and then can, when you initiate that site recovery for that workload or that application, it moves that all into the Azure environment from your data center or from one Azure site to another. You can get back up and running in a much shorter time frame than simply the manual process of Azure backup. So all three of these as a business continuity and disaster recovery ecosystem all fall in line and help to build that business continuity structure around your organization. So it's important to know those. One key thing around Azure Site Recovery is some of your exam questions may be, if anybody's ever taken a Microsoft Azure exam, there you get questions where it's put these particular tasks in order. You'll get some of those around Azure Site Recovery and Azure Migrate, for example, of what you need to do and what your process is to do those.
Dwayne,
yes.
sorry.
You have another question there?
Another question, and somebody has their hand up, I think. So for ZRS, we also have 3+1 copies, right? Well, question mark.
Zone redundant storage, you get 3 copies across the zone. So where LRS is within a single data center, zone redundant storage is across the 3 data centers. So you still get only 3 copies. There's not an additional copy. You're getting those across your 3 data centers.
Cool. And someone has their hand up. I don't know if it's to ask a question or not. Could you please type it in the chat box? If not, we can come back to you at the end. Let's do that.
All right. Are we seeing my Azure portal screen now?
We are.
All right, great. So couple things to show around this. I wanted to show, if for those of you that might not be familiar with the Azure portal, I wanted to make sure everybody saw, the ease of creating a virtual machine, as well as we'll talk a moment about the recovery services vault. So I have created a resource group already, but we'll go in here into creating a virtual machine, and we'll select my group and give your virtual machine a name. You select your region. So when we talk about zones and all, when we create, say, Central US and select Central US, just to take that ZRS a little step further, where you have the when you pick a region, say Central US, there is generally 3 data center local data centers that are on the campus that is that zone. And so if you're selecting zone redundant storage, you're putting that storage in 3 different zones. There's a little bit more of a cost to it than local redundant storage, which is just 3 copies within a data center itself. Seems like some people.
Yeah, Dwayne, someone is asking if you can zoom in the
okay.
browser.
Yep. All right.
No, they're asking to zoom out, but other people are able to view it fine, and I can see it fine. So
okay.
Yeah.
Maybe just a little bit out and see if that helps.
Zoom out a little.
Cool, thank you.
All right. So one thing that Microsoft did put into the Azure portal not too long ago was they added your availability options right into here, where you can pick that you want to create your availability set right within the Azure machine image build. And we'll just show you that real quick here. I'm not going to create these virtual machines here, but this kind of shows you here the fault domains and update domains. And it's important to know that when we were talking fault domains and this is across multiple servers, if you're picking the availability zones, it's going to ask you how many zones you want to use, which, like I said, the zones are generally 3 zones per region. But you have the ability to spread those servers across three racks. So the fault domains are your racks, and then your update domains are where you can spread them across multiple hosts, and you can go up to 20. Now, what I was saying around these availability sets is you're going to pay for how many you scale on here. So in this example, I've got 20 servers across 3 racks. So I'm going to be paying for 20 times, 20 servers based on the servers that I select and the cost per month of those servers. So it's very important to understand what level of budget and cost you want to put on here. So if you're going 3 servers or more, it's always good to do the fault domains, because it's not going to cost you any, much more from a standpoint. You're paying really on the update domain standpoint. So, it's not going to let you pick only 2 servers. So you can pick 3 and 3. You got 3 servers across 3 different hosts on 3 different racks. So you're going that standpoint. You might want to go a little bit further up, pay for 5 servers. That's up to you, but that's how the cost around availability sets works. And I'm not going to continue that. I just wanted to show everybody how that worked. And the same thing, with availability zones, you can spread those across multiple data centers from that standpoint. But again, you create an availability zone with 3 servers, you're paying for 3 of this machine. And I've only got the burstable machine right now in here. So it's important to, just understand, if you're picking your machine, you can select your size. It'll tell you your cost per month right here. So you can budget it out right within here that, okay, I've got this budget for compute resources on this application as a standard, and you can find what size you need and build it from there. We'll go more when we talk about security, but always good practice to turn off your inbound ports. So I'm not going to go a deep dive into that for everybody, but important to just know, good best practice to turn off public inbound ports and public IP addressing on your virtual machines. Use load balancers on the back end, and we'll talk more about load balancers Friday. I have that in some of the platform service discussions. So I'm going to go out of this. I'm not going to create this right now. You have some more questions, or?
It's okay, I think.
Right.
Yeah, we're fine. We're good.
All right. I have my watch notifying me whenever a question comes through, so I'm trying not to look at it, let you handle that, but I know when people are asking questions because I feel it buzz on my wrist. All right. The other thing, a couple of other things I wanted to show, as we get to the end here is we can, for scale sets, we talked about scale sets. That is actually within a different area here. And if I do virtual machine, you can see there's a selection directly for scale sets. And here is where I would create my virtual machine scale set. And again, I can select my group. I name my scale set. Put it in. I can do a scale set across an availability zone. So if I don't want my servers to be in one data center, I can do that. If you were to create an availability set outside of the creation of the single virtual machine, like I just did, you can go into availability set, and I'll show that in a second as well. Again, here, we have our server types that you can see here, all lined up. You can pick which one you want. I always find it entertaining that Microsoft defaults to a Linux-based operating system rather than their own operating system, which I think that's their way of just telling people that you can use Linux within a Azure environment. It's not just default to Windows, as well as the, obviously those are less costly being the open source operating systems than a Windows data center operating system. But you can see there's different login ways within the scale set as well. I'm not going to go, you have the big thing here is with scaling is you set how many what your instance count is, and it can be set from 0 to 1,000. Generally, you're going to start at 1 though from your count, and then you can create a scaling policy here of what you're going to have as your minimum number of virtual machines, what your maximum number is. So like I said, this could be up to 1,000 virtual machines, and then set your scaling policies. So you set your set the conditions that are going to essentially run that action to increase your virtual machines. So here it says 75% on your currently running virtual machines. If your compute hits 70 CPU percentage hits 75% utilization for a period of 10 minutes, I'm going to increase and scale out an additional virtual machine. When it goes down to 25%, I'm going to decrease it by a virtual machine. So this is how you control your cost and control your usage. And you can then also have these policies here of which instance to remove and how you balance that. Balance it between fault. So if you are running these in a availability set, you can balance them between fault domains and availability zones. Here, balance across availability zones. So you can see there's some rules that you can put into your policy as well and build those to protect yourself and maintain that availability set. Kind of works in conjunction then with the scale set within this configuration, as you can see. Exit out of this one here, and we can go. Yep. Yep.
Does this threshold mean for all of the VMs combined, or any single one of them could cross 75% here in this example?
It's across your scale set. So that's why you build the scale set kind of on its own rather than as a single virtual machine build. Your scale set, it's looking at 75% across your compute that you're using at that time. So if you've already scaled, so it starts, if you start at 1 virtual machine, you hit 75% on that virtual machine. Now you're running 2 virtual machines, and you're not going to scale out again till the CPU utilization across both those virtual machines hits 75%. So it's going to look as a conglomerate of the virtual machines you have running before it scales out again, not just a single virtual machine if you start scaling out multiple virtual machines. So another way to create your availability set here is you can create this directly as well, and you can see here you have your name, and you can do the same thing as we did within that virtual machine here as well. You can add as well virtual scale set into your availability set after you've created your availability set. So that's something to understand, that they do work in conjunction with each other a little bit, but again, important thing around availability set is you pay for exactly, you can see here you got your default. When you create this, if you leave this as the default, you're going to pay for 5 virtual machines as a default. Even if you have a scale set built into there, there's going to be other virtual machines that are going to run in there as a standard baseline for your availability set.
Cool, thank you. We have another question.
Yep.
Do the scale out conditions have to sustain for some time in order for the scaling to kick in? Else there can be a case where the scale out condition might be true for a very short period and the condition changes by the time the scaling happens.
Yep. Yep. I kind of might have glossed over that rather quickly, but when you create your scaling conditions, you create that custom, you can see here that there is a threshold of time within your scale out requirements. So you're creating a scale, you're creating here your condition of time. So you can make this, you can make this, here's 10 minutes. So here's, you can always scroll your mouse over these eyes and it'll give you additional information, but you can see it defaults here at 10 minutes. So you're generally queuing those virtual machines. Your Azure your monitoring is probably running, every 2 to 5 minutes. It's hitting those virtual machines to get the information and feeding that information into Azure Monitor and into Log Analytics, which is what is making the determination to run that action and to do that scaling. So here it's making sure that you're not getting just a false spike in that first 5 minutes. It's actually hitting it really at the second duration going through and saying, okay, this has been running for 10 minutes. So it's not just a quick spike. It seems to be a longer duration spike. And now I need to scale out. So that's where you're going to hit that and where you're going to define that. If you feel that you might have quick spikes that last longer than 10 minutes, you might want to make this 15. You might want to make it 20. It's up to you in your environment how you want to configure it, and you do have the flexibility to do that. Last thing I wanted to cover real quickly, and I'll try and build some more when we talk about data and storage and security and all as well. But I wanted to show everybody just the recovery services vault and what you can do in terms of backups and within here. So and should have created. I forgot to deploy this before we started, so this shouldn't take too long to deploy because I already have a resource group to use. But while we do that, we'll wait.
There's another question here. Are the additional machines pre-created or are they created just in time?
For a scale set, it is just in time. So it does not, like I was saying, a scale set, it deprovisions and provisions as needed. So if it's a big virtual machine, it might take a little while once it says to scale up for that virtual machine to turn up and get running for your application. So it's important to understand that. Yep.
And then what about scaling in time threshold and not scaling out? I suppose you've maybe just answered that with it being dependent on maybe the size of the VM.
Right. It's going to determine, based on the size of the virtual machine, how long that might take to, it's good to understand how long a particular machine might take to provision and deploy within Azure, because you're going to have a lag once that condition gets triggered and that action gets triggered for that to spin up.
Yeah. Okay, cool.
All right, so last thing real quick is just, you can see here, we've got your site recovery vault, recovery services vault created here. And you can see you have backup jobs and you have site recovery jobs. Your backup jobs are really what's running and what is using Azure Backup. Your site recovery jobs are your replication jobs. Those are those jobs I was talking about when you're using Azure Site Recovery. So you can initiate and create a backup within here, and you can see I've mentioned the different workloads in Azure that are covered, SAP HANA as well. So they've built this in. I was looking at this when I was creating the slide presentation. I don't remember seeing SAP HANA last week, so this might be one of the new services. But you can see you've got databases, whether it's SQL or SAP HANA, Azure File Share, and virtual machines. If you go to an on-premise, there are actually even more that you can do. You can do a SharePoint server, Exchange. A lot of these aren't in the Azure environment because you're going to be looking at, they want you to use, SaaS services and Office and Microsoft 365 for those. You could do system state and bare metal virtual machines. You could do a Hyper-V virtual machine, VMware. You could build all those in there, files and folders all within your backup. Site recovery, and here's an important thing to go in. I recommend you go and create your own recovery services vault and study these steps when you're creating your creating a Azure Site Recovery job, what the steps are, and this will step you through and show you what you need to do. It's important to understand what those steps are when you're going into the test, because you may be asked what's this process in order. And one of the important things is, if step number one is generally create a recovery services vault. So understand that we had to create, before we started Azure Site Recovery or started Azure Backup, we had to create that recovery services vault. So that's really the only thing. I'm going to try and build some more time for site recovery in a later session, but we're getting to the end of the hour here, and I want to be cognizant of everybody's time and appreciate everybody taking the time out here today. But important things, next steps. I talked last session about the self-assessment tool. Understand where you're comfortable within the environment, where you're comfortable within the objective areas, and this link takes you to a nice self-assessment. Microsoft Learn, understanding Microsoft Docs are all great areas.
Okay, what do we have?
Hey guys, someone's just come off of mute. Can you make sure you're unmuted? I can't find you. Thank you. Oh, no. Okay.
All right. So, this is a busy week for the Cloud Lunch and Learn, because in the United States we had our 4th of July holiday last Friday. So we moved this one to Monday, but now we're going to be doing the next 4 successive Fridays starting on the 10th. We'll be hitting platform services. So that is it for me. And if you want to, as you talk about this, Lisa, if you want to share the quick quiz, we're going to work on getting a lucky winner discount code on an exam based on how well you do on my quiz and what your and then we'll, based on how many 100% we get, we'll do a drawing for a voucher code for everybody.
Okay, guys, so I've popped a few things into the chat. First of all, we would love if you could provide us feedback on this session. So I've popped the link in there for feedback. And I just want to say a big thank you to Dwayne for this session. Thanks to everybody who's joined. Our next session is on Friday, so I've popped the link there as well for you to sign up. And then we've got obviously the link for the quiz. And if you've not already, please fill out the form that you see on the screen right now. You will get access to relevant documentation to this session from Microsoft. And basically it looks good for us. So we'd really appreciate it if you could do that. And Dwayne, someone's asking to post a link to the self-assessment.
Oh, okay. Yep. We can. We'll put this presentation in the Cloud Lunch and Learn GitHub.
Yeah.
And you can find these self assessments very easily. It's Build59's. He's Chris Peachman's a very active participant on social media as well. But if you just you can find it by finding the build59s.com blog as well. But we'll make sure that this presentation is out there with all the links so you can get access to them as well.
Yeah, excellent. Okay, guys, if there's no more questions, thank you so much for joining. I'm going to stop recording now and looking forward to meeting you all back here on Friday. Thanks, Dwayne.
All right, thank you. Have a great day, everybody.